the expression right here and saying, all right, which of them matches up. I don't think that that's wise. I don't think we should just stare at that and try and connect right there. I just don't think at this point in the game that's going to work very well. What I would suggest doing is this. Start with A and try to convert A over to limit sigma like we did before. And if that doesn't work, maybe convert B over to limit sigma, but maybe somewhere in there you start to see a pattern and you can say, oh my gosh, I see it. There's the answer. That makes sense? And eventually I'd hope that you'd get to that place where you could say, I can kind of pick through it without having to do all that detail. But for now, I think this is a good method. So is it okay if I help you with the first one?
Yes.
Okay. So what I'm going to do, just to be clear, I'm going to take A, which is what we call a definite integral, and I'm going to convert it over to what a definite integral really is, which is the limit as n goes to infinity of sigma of something. Okay? So I'm going to just start by doing this. I'm going to say limit as n goes to infinity of sigma from 1 to n, from I equals 1 to n, sorry. I equals 1 to n. So aren't all these going to have that? I think I pointed that out last time, that anytime you're going to do a limit sigma for area under a curve, they will always have a limit, and they'll always have a sigma. That's why they're called limit sigma. And then the stuff that goes in the inside will be unique, but it's the same kind of thing. So let's stop right here. What is the general concept of what goes inside the sigma? It's always base times height. So what are we really talking about? Rectangles area. So base times height. And so that's what I'm going to put in here. I'm going to say I've got a base, and I'll do that first. The base is usually the easier one to do, and then the height we'll come up with next. So the base length is essentially the width of the entire interval divided by the number of rectangles, which is n. So how wide is the interval on A? From -2 is the low value up to 7, 9. Yeah. And so the base length would be 9 over n. So at first glance, you look at this and you say, maybe, wow, look at that. They match. So that's a good start, right? 9 over n, 9 over n. We're trying to match these things up. So that's encouraging at least. Let's see how the heights work out. So that's a base. Here's the height. I've said this a lot. I'll say it again. I'll say it slow. I'll try to let this sink in. The height of the rectangle is based on the y value of the curve. The height of the rectangle is based on the y value of the curve. And the y value of the curve, according to A, is negative x cubed plus 5, right? So for my height, I'm going to put negative blank cubed plus 5. So we start to see this taking shape. We see the plus 5 matches the other plus 5. So that's kind of nice. I mean, I'm referring to these right here. So it's looking like maybe this will work out. But we got to deal with the input. So does anybody remember how we handle the input here as far as like the first number that we always put in there?
It's the start of the interval.
Yeah, the lowest number in the interval. And so for part A, that would be which number? -2, right? So the lowest possible number to plug in there would be that -2. So I'll put -2 plus, now let's remember, as you move from left to right, from -2 over across the picture, making your way towards 7, every time you move, how far will you be moving? 9 over n, like the width of a rectangle, right? And so 9 over n, we already determined that, but we have to put the I in there because the I allows us to actually move across the picture, right? It allows us to do the first one, then the second, then the third, then the fourth, and so on and so forth. So now we've done it, right? We look at that, and now we compare. Is that equivalent to the limit sigma we were given in the beginning? But isn't it ultra close? What's the only thing that's not the negative? Yeah, so this negative right here that I just sort of covered up is not in the one that we were supposed to compare to. So maybe this helps you. Maybe this helps you to look at the other options and determine, you can kind of see a pattern a little bit. Can you guys eliminate any of the other options right now? So D, so why could we eliminate D? Because, okay, it's the same negative, and I heard somebody say the interval's messed up. So if D were the answer, your low limit is 0, like the low value in the interval is 0. Instead of a -2 right here, what would you have? A 0. And we don't have that. So I think there's two good reasons to eliminate D. The low limit startup, as well as that negative that we've already figured out. That shouldn't be there.
Would B be the same?
So B What's wrong with B?
Because it also has zero.
Yeah, the interval starts at 0, so we should have a 0 plus. So we finally arrive at C, and it's like, by process of elimination, it seems like we've eliminated everything but that. Sorry, let me do a little better job circling that. There we go. But let's make sure it actually makes sense. A low interval value of -2, that does match, doesn't it? And then, of course, -2 to 7 has a width of 9. We don't have that unneeded negative sign. I think we could conclude for sure, yeah, C looks like it's the one. Okay, that makes sense? Let's be honest. Like when you first look at a question like 3, isn't there just like a little bit of a twinge of terror? Like you see all those symbols and you're just like, oh man, symbols. They're crazy. How am I supposed to equate all these things? It can be a little intimidating. I definitely understand that. What I would like for you to do though is break it down into those little pieces. They all have limit sigmas, right? And the inside of the sigma is always a base times a height. And what's the hardest part of the height? For you guys, I don't know. I feel like there's a hard part of the height. When I say the height, I'm talking about this part over here. Oops. What's the hardest part of that? Okay, I'll share. All of it? Okay.
The height.
The height in general, the whole thing. I've always felt like the input was the hard part. Because, isn't the framework just essentially x cubed plus 5 or negative x cubed plus 5? So it's like negative input cubed plus 5. But then being like, okay, what goes in there for the input? That's the part where you got to think, okay, low value of the interval plus, 9 over n I. I mean, coming up with that to me is a little bit tougher. But I would encourage you to break it down into those little chunks like I've tried to do for you. I think if you do that, you have a good chance for success. Here's what we'll do. As we go throughout the next week, like when we come back from Thanksgiving break, we'll pepper in a couple of these. I'll just make a couple of them up.
Send Natalie Kuzia to the front desk and have her bring her car keys.
Ooh, parking violation. Dun, dun, dun.
That sucks.
Natalie is on her way.
I say Chinese stuff just like
Oh.
Wait, where did you?
Oh, like by the salt? No.
Hey guys, if at any point any of these concepts doesn't make sense, you got to say something. But let's read through this together. Sometimes you'll have a function that you're finding the definite integral of, but part of it is going to be below the x-axis, and so it's like, what do you do with that? So let's talk about that. First of all, we will never reach a conclusion that the area is negative, because area, just by categorically, area cannot be negative, right? It just can't be. It's always going to be a non-negative number. But we can still do an integral and still get a negative number that comes out of that. And we'll talk about why that is. So let's say that we were doing this first integral here, the integral from negative, yes ma'am.
Are we supposed to be able to solve like any of this? Like the
Okay,
go back up.
so you're pointing at old stuff. No, we're not there. Well, yeah, kind of on this one, yes, a little bit. But there's another way that's more adaptable and also easy. The way we're going to do it right here is you got to have like nice geometry shapes. We won't always have that, but the easy button on the other stuff will work too. You didn't watch it either. Very interesting. Okay, so integral from -4 to -1. Aren't we talking about essentially this region right here?
Yeah.
Okay, so I want you to think about some characteristics of that region. Number one, that region is below the x-axis, so every single y value on that part will be negative, right? Every single y value will be negative. There's no avoiding that. So let's go back a little ways. Do you guys remember what a definite integral, that's the one with the little limits, from like 1 to 5 or whatever. What is a definite integral really?
Area under.
Okay, it works with the area under a curve, but let's go back. What have we been working with in the last day or two in regard to the details leading up to what a definite integral is? What was the previous problem done 3 minutes ago all about? Limits and?
Limit sigma.
And remind me, what is a sigma again? Sum, and limit is n goes to infinity. So if somebody, let's put it this way. Let's say that someone was watching you do your homework or take your test or something. They're peeking over your shoulder and they point at an integral symbol, right? So they point at this and they say, wow, what are you doing? And you're like, oh, that's just a definite integral. And they're like, That sounds like foreign language to me, definite integral. What is that? If somebody were to ask you, what is a definite integral? Here's how you could respond. You could say, it is an infinite summation. And they might ask you they might ask you more. They might say, what's a summation? Now, you could break this down, couldn't you? What's a summation?
It's when you add stuff.
Adding stuff, this plus this plus this plus this. And because it's an infinite summation, does the plus this ever stop?
No.
So that's why we have to use a limit. We're saying, okay, what is the pattern if we take a bunch of stuff, we add it up, and the bunch of stuff never really stops? That's what a definite integral really is. Guys, it's adding things up. That's it. Forever. And that's why it's in a calculus class instead of 6th grade math, right?
Like adding zeros to a number.
So, if we were to take a look at the integral from -4 to -1 and try to figure out what that is, because a definite integral is simply an infinite summation, wouldn't it be adding up a bunch of negative numbers? Aren't all the y values negative there? So, what would you predict the answer to our integral from -4 to -1? What would that have to be? It would have to be negative something, wouldn't it? Because you're adding up a bunch of negative numbers. Because these are nice lines, linear, piecewise graph, because that's what these are. So because these are lines, what we can do is we can actually just use geometry to do this. It's actually a really, really simple problem. This would be the easiest button of all, to be honest, talking about an easy button for these. What is the area of that little triangle that I just highlighted? 1/2 BH. What's the base? 3. The height is 4. So what's the area of that?
6.
1/2 times 4 times 3 is 6. However, I think I would write, just for my own self, just a little note to self, it's -6, because I do an integral. The integral is going to spit out -6. Oops, let's try that again. The reason why the integral is going to spit out -6 is because a definite integral is simply an infinite summation, and in this case, it's a summation of a bunch of negative numbers. So it's going to total a negative number, -6. What if I decided to, do a little bit of a bigger integral, -4 to 2? That would include this then, wouldn't it? Okay, so if I was going to expand my interval a little bit, I could use area again. What's the area of that other triangle? It's also 6, but isn't that above the x-axis? So I'd be adding up a bunch of positive numbers, so what would I write there? Just a +6. So as I think about accumulating the area, adding up a bunch of numbers from left to right, what would you guys guess the integral from -4 to 2 would be?
0.
It would be 0. It would essentially be -6 plus 6, which of course is 0. This is not in your notes, but what if I was going to ask you a further question, just a little bit further, and say, all right, I get, the integral is going to go -6 plus 6, you're going to get 0. But what if I said, what is the area between the function and the x-axis from -4 to 2? What would you say there? 12. Now it would be 12 because remember, area is never negative. I used that key word. What is the total area between the function and the x-axis? That would be 6 plus 6, which is 12. So the integral is simply going to add up the stuff that you tell it to add up. Whereas if we're talking about area, you've got to pay close attention. Is it above or below the x-axis, and how's that going to work? Let's go ahead and take a look at that last little question at the bottom there. It says, what is the area between f of x and the x-axis on -1 to 4? So that would be from here over to here. So see if you guys can figure out the area on that interval. So, have you guys figured out the area, that last little piece that we haven't done yet? On the right, what is it? Well, let's see here. It's a triangle. So what's the base length on that?
2.
And the height? So the area would be? 4. But it's below the x-axis. So maybe you would think of it as -4. But remember, this used that keyword, what is the total area? So what do you think the total area is? 10. Agreed. Let me take it a little bit further. What if I asked you this, though? Integral from -1 to 4 of f of x dx. What would you guess that is?
2.
Yeah. 6 plus -4 equals 2. Remember, the integral doesn't really care about area. The integral is simply going to say, are you adding up positives, are you adding up negatives, or is it a mix? And if it's a mix, you got to, consider that. If it's negative, you got to consider that as well. All right, still doing okay?
So you're saying that 10 is the answer, right? Not 2?
So I asked two different questions. So the answer to this question is 10.
Okay, yeah.
The answer to this question is 2.
Okay.
Yep, good question. All right, we okay? All right. We'll run through these. Like I said, there's 2 examples at the end. I'll have you guys try on your own. So the first one is the integral from a to a. Knowing what you know about a definite integral, what would you guess the answer to this is? Integral from a to a. In other words, the limits are the same. 0. How much area could you fit between a and a? There's no room, right? There's no room for any area, so it'd just be 0. And believe it or not, you very well could see an example that looks sort of like that right there. It's not going to be quite as simple as you think. It's not going to just ask that directly. It could be within kind of a bigger process, but you very well could be asked an example just like that. And so if you see the integral from 4 to 4, if the limits match, the answer is just automatically 0. There's no area possible between, because there is no between. And so you just say 0. All right, take a look at number 5. For those that watch the video, the intro video for 4.4, number 5 might make a little more sense. It's a little bit of a deeper meaning than just what's presented here. But what this is going for is the integral from a to b of f of x is equal to the opposite of the integral from b to a. With all the different integrals you've looked at, hasn't the physically lower number been numerically lower? And then the higher one has been numerically higher. And so we might, in some cases, find a need to switch the limits around. And you're okay to do that as long as you switch the signs. Switch the sign of the integral. So if you flip those limits around, just change the sign from positive to negative. Yeah, so notice here, it's the integral from a to b, now it's the integral from b to a. I'm okay doing that as long as I change the sign on the outside. So my example, take a look at it. Notice how the lower limit is not actually numerically lower. So this is summing the other way. So instead of adding from left to right, this one is adding from right to left. Most often we're comfortable adding from left to right because that's what we typically do. And so maybe we want to switch it around. Maybe we could say, I don't like that. I want to have it to be the integral from 2 to 5 of f of x dx. You are perfectly okay doing that as long as you change the sign on the outside of the integral because it's just the opposite difference. For those that, again, those that watch the video maybe will understand that a little bit better. Okay, there's a couple more to check out. I think this one will make a lot of sense if you think about area. So I've got this function. It's curvy up there. You can see it. I've got various intervals from a to b and then c. So if you think about this right here, the integral from a to b, wouldn't that be from here to here? And then the integral from b to c would be over here. Notice that both of those integrals for their limits have b as a common, right? Common limit. So if I were to take the area from a to b and the area from b to c, what would that equal?
A to C.
Yeah, the area from a to c, right? The whole thing you just added up, and the area is going to be the total area. That's going to be the sum of those little parts. And so maybe you can see that taking shape right here. Integral from a to b plus the integral from b to c would equal the area under the entire interval from a to c. So an example like the one below, what could I do with that? The integral from 1 to 3 plus the integral from 3 to 7 would equal 1 to 7 on the integral. Yeah, so the right integral from 1 to 7 of f of x dx would be equivalent to that. Okay, like I said, I think there's 2 more. Let's check it. Okay, so we've seen number 7 before. If you were going to describe k in number 7, how would you describe the k? What is it? Not just a constant, but a constant multiple. So with a constant multiple like before, we can just bring it out. So I would write this. K integral from a to b of f of x dx. You can do whatever you need to do with the integral, multiply the k back in the end. So the example, what needs to come out in the example? The 7 gets to come out. That's a constant multiple. So 7 integral from negative 5 to 8 of f of x dx would be that property there. And then finally the last one, we've sort of done this already. We did it a little bit, again with the video, you saw this to some degree. If you're doing the integral of a sum, you can actually just go term by term. So the way you could break apart something like number 8 is you could say, well, the integral from a to b of f of x plus or minus g of x is equal to the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. And so doing so allows you kind of deal with them individually and maybe have a custom approach to each one. Sometimes that's a good way to go. And so if you look at the example down below, can you see it's a sum? And so what I could do with this, if I needed to or wanted to, I could write the integral from 3 to 4 of x to the 5th dx plus the integral from 3 to 4 of 5 sine x dx. There we go. There's one more thing I could do with this. Do you know what it is?
Move the constant,
Say again?
move the constant multiple.
Yeah, get the constant multiple out. So I have a question for you. We want to get the 5 out. Would the 5, would it come all the way out front and apply to both terms or just one of the terms? Just the second term, right? And so that's actually a good reason to do this, splitting up things. So we'd say this is equal to the integral from 3 to 4 of x to the 5th dx plus 5 integral from 3 to 4 of sine of x. So potentially makes it a little bit easier. It definitely makes it more clear what's going on, and sometimes that makes it easier to do. All right, so what's left here on this particular part is a couple of property examples. So if you guys would take a minute and do numbers 9 and 10, feel free to discuss, do on your own, compare answers. I'll give you guys maybe like 5 or 6 minutes to, about 5 or 6 minutes to do these. We'll compare answers in the end. So get after it, try numbers 8 and 9. You felt a little bit more involved. I don't know. So like with number 9, did you guys bring the 2 out?
Yes.
2 gets to come out, so it'd be 2 times the integral from negative 2 to 9. But of course, if you looked up above, there is no integral from negative 2 to 9, is there? So, well, kind of, yeah, not in that form. Yeah, you're right, not in that form, but it really is there. Then did you guys notice that these limits were kind of backwards of what was presented above? So you're allowed to switch those as long as you do what? Flip the sign, make it negative here, yeah. So minus integral from 3 to 7 of g of x. So then, earlier I said there is no integral from negative 2 to 9. You said, well, actually there kind of is. Isn't it right here? Isn't it just the sum of those two? So you could just do this, negative, or not negative. Oops, let's go with that. We would go 2 times, so from negative 2 to 5 is 4, and from 5 to 9 is negative 12. So you could just do something like that, right? Just the sum of those two would give you the whole integral. Minus integral from 3 to 7 of g of x was 10, and so we could write minus 10. So let's see how this worked out. 4 plus negative 12 is negative 8, times 2 is negative 16. Did you all get negative 26?
Yes.
Yes? Okay. Doing okay? Any questions, follow up on that one? All right, so number 10, slightly less involved, but still challenging. I would get the 3 out. I would also get the 4 out. They're both constant multiples. So you could write this as negative 3 integral from negative 2 to 5 of f of x dx plus 4 integral from 3 to 7 of g of x dx. All right, so we directly have these, right? Negative 2 to 5 on f of x is 4. So it'd be negative 3 times 4 plus 4. And then it's 10 for the other one. So this ends up being negative 12 plus 40, which is equal to positive 28. So that work out okay? I see some smiles, some happy faces, even some fake claps over there. I like it. We're good? Okay, very good. You can watch the video. This will be a little bit of a help, but you want to see a little bit of the background. We'll see how this goes. I would expect you to be able to do this. So I'll tell you what. Let's approach it from this perspective right here. With number 4, I feel like if you learned what you need to learn from the video, you could do number 4 in 3 minutes. 3 minutes. All right, so give it a shot. I'll give you 3. Like number 4, and I would expect that you could do this without a calculator. There's going to be some. This is on the borderline. This is on the borderline of that kind of that edge of calculator or no calculator. If the calculator were active, we would approach this a little bit differently. But let's pretend like there's no calculator. Here's how this goes. Step number 1 here is to find the antiderivative. So we're just going to use the power rule 3 different times. So the antiderivative of x to the 3rd is 1/4 x to the 4th minus the other one would be 2/3 x cubed And then the antiderivative of 5, of course, is just 5x. Once you find your antiderivative, the way that we handle those limits of integration, the 2 and the 4, is you put a line over here. That line means evaluated from 2 to 4. So the antiderivative evaluated from 2 to 4. Here's how you basically execute what we call the fundamental thermocalculus part 1. You plug in the 4, you plug in the high limit, the number that's physically higher, and you plug in the lower number, and you subtract. So I'm going to plug in the 4. So it's going to be 1/4 times 4 to the 4th minus 2/3 times 4 cubed plus 5 times 4. And then as I said, we're going to plug in the 2 and subtract. So it's going to be 1/4 times 2 to the 4th minus 2/3 times 2 to the 3rd plus 5 times 2. So I plugged in the 4, I plugged in the 2, I hope I did it right, and I'm going to subtract. Madison, your question.
Just when you say the higher number, do you mean the greater number?
The
one
physically
more?
higher number.
Physically, okay.
Yep, the one that is like, has a higher elevation. We could put it like that. Okay, so you might be a little stressed about 4 to the 4th, but the reason why I think you could do this without a calculator is wouldn't the 1/4 cancel with one of those 4s?
Yeah.
Making it effectively 4 cubed, which is 64. So 64 minus 4 cubed, again 64. What's 64 times 2? 128. So 128 thirds plus 20 minus 2 to the 4th is 16 times 1/4 is 4. 2 cubed is 8 times 2/3 is 16 thirds. So there's your second term. And of course 5 times 2 is 10. I'm just going to add the numbers that I can easily add. 64 plus 20 is 84. I'll come up here. So 84 minus 128 thirds minus, inside there, 4 plus 10 is 14 minus 16 thirds. I'm going to approach it from this perspective. I'm going to go 84 minus 14, which is 70. And then I'm going to go with negative 128 thirds minus negative 6. That's really plus, right? So what's negative 128 plus 16?
Negative 112.
112, right? So negative 112 thirds. And finally, I'll leave it for the very end. What is 70 written as thirds?
70, that's about 23.
210. Common denominator of 3, right? So 210 minus 112, please don't pack up yet, is?
98.
98. So our final answer would be 98 thirds. And again, this is like right on the border of would I give you the calculator for this or not. This would be one of the tougher arithmetic ones. Very doable, but it'll make you slow down and do your arithmetic, right? So if you have not watched the video, you have a new homework assignment. Those that did watch the video, you don't. I will see you guys tomorrow. We'll keep working through 4.4 tomorrow. Have a great day. Drive safe.